Hello and welcome to this repair tutorial, and today we're going to look at a Pioneer and the model number is A10AE. In terms of specifications, the amplifier will provide 30 watts per channel into 8 ohm speakers, but if you connect 4 ohm speakers then this will increase up to 50 watts per channel. And then frequency response 10 Hz to 100 kHz, and then total harmonic distortion comes in at 0.05%. And this amplifier supports a direct connection from a turntable, and that turntable must have a moving magnet type cartridge, and your input millivoltage there is 4. And then for your other inputs, which is CD, SACD, line 1, 2 and 3, the input is 200 millivolts. It also provides a line output, and you can select direct mode, which will bypass the tone control circuits, and you have individual controls for bass, treble and balance. Now this amplifier I believe was probably released around 2018, and it is a fully microprocessor based amplifier, but for this unit it doesn't support a remote control, so all operation is manual. And then because it's a microprocessor based amp, what they've done is they've embedded some functionality into there. So what I'm alluding to is if, for example, you wish to switch between the default setting, which is 8 ohm speakers, to 4 ohms, what you're able to do then is to select it via the front panel. So you just keep your finger pressed on the direct button. The CD, the SACD and also line 1 will start blinking, and then you can clear it back to default if you wish. And then to reset the amplifier is quite straightforward. You just keep your finger on the standby or power button and then the direct mode, and then it will clear and then go back then to default. The amplifier also supports this auto power off function. This is very common in all modern day amplifiers. Default means that it's off, but if you enable it, and again that's dead easy, you just keep your finger pressed onto the standby button, and then what will happen is that the loudness and direct buttons on the front will flash. Then you can enable it, and then if you don't have any audio connected, or it doesn't sense any audio connection for 20 minutes, then the amplifier will then go into standby mode. Now before I sort of get into what was the issue with this amplifier, I think what I want to do first of all is just sort of cover one point, which is this aspect right to repair. And there is different sort of legislation which has come in over a number of years, and this affects all consumers with regard to different products. What it really means is that manufacturers now cannot sort of hide behind a non-disclosure agreement and say, well, we're not going to provide you with any service information or, for example, any spare parts. But unfortunately the legislation is different depending on which country you're in, and then also as well the wording is such that it affects certain goods like white consumer goods like fridge freezers and this type. It also links directly to what we call e-waste, because if you have the ability to repair something, then of course you can extend the life of the device. Now the reason why I mention all of that, normally for the video tutorials or repair tutorials I do provide an extract of the service manual, but not in this case. The service manual for the amplifier is not in the public domain, and the company Premium Audio Company actually acquired Pioneer, and then it also acquired a number of other leading brands, and in there as well is Onkyo. And Onkyo, probably around 3 or 4 years ago, effectively went into liquidation or into receivership, and then it was then sort of bought out to continue on with that brand. But in terms of inside, I can't show you the service schematics, which is a little bit disappointing. So let's sort of get into what the issue was when this amplifier came in. Well, what would happen is that the amplifier would go into protection mode after a period of operation. And for this amplifier, you don't actually have any speaker protection relays. And what the amplifier does is if it senses a fault, it will operate the relay on the input startup board and will de-energize it. And what you could hear is that the relay would then just de-energize and the amplifier will then turn off. Now from a repair point of view, that makes your work a little bit more challenging, and the reason why is if you disengage the power startup relay, it will then shut off the power then to the power transformer, so you're not going to be able to really make any voltage measurements. Of course you can on the startup board, but you can't sort of on the main amp board. And then you kind of left then to doing more like resistance or static checks to try and isolate where you've got an issue. So what I'm bringing to your attention next is the measurement of the bias. Now you have a bias setting both for the left and right channel, and what I'm showing you here is the bias value which can be read directly on the test points, and I'll sort of get into that in a moment. Now the one channel, as you can see here, is about 8.11 millivolts, so that's perfectly fine and there's no concern. But if I then move now to the other channel, what you can now see is that you're looking at 1.468 volts. So clearly we've got an issue, because that should not be that high. And also as well, when you look at the way in which these amplifiers work, and this is all types of amplifiers that use a bipolar type transistor output, what you have is the NPN transistor, and then it then connects then to a emitter resistor, and then there will also be another emitter resistor, and then a center point which will go off to your speakers or to your speaker protection circuit, and then you'll have the PNP transistor, both for the negative and then positive drive then for the audio output. Now when I did the measurement here, it was high as you saw, but if you went and measured the voltage on the base of each of the transistors, and of course depending on if it's a PNP or NPN, it will either be positive or negative, it should be about 1.2 volts or minus 1.2 volts on the base. And what you found here on the defective channel was that it was around 0.5, so really almost like below the turn on voltage for the device. And then here what I'm highlighting is the dual emitter resistor. So this is a single device, and it's 0.22 ohms times 2, and it's a 5 watt. And then that's just in front of the two audio output transistors. And then just on the left hand side I'm showing you a test point, and that's where you would use your hook clips to connect to your multimeter and then to measure the bias. And then here, if we just sort of zoom in, what you can see is the emitter resistor. And as I said, this is a dual pack type. So you have a connection left and right where I've drawn the circle, and then the center connection. So one is going to the NPN, one is going to the PNP, and then your center point connection then. Now, before I sort of stripped down the amplifier, what I did was just to sort of hook the measurement leads around. And what you can see here is if I do a static resistance check, there's no power being applied. One half of the resistor, or one of the resistors within the dual pack, is reading very, very high resistance. You can see here 0.378 meg or roundabout. And then if I sort of flick down to the other channel, what you can see here, of course it's not going to read 0.22 ohms exactly, but you can see that the resistance reading is very low. So that's telling you that there's no issue with that side of the amplifier, and also with the dual pack emitter resistor. So what you do is you of course strip down the amplifier, and I'll sort of get to that in a moment. And then what I'm showing you here is the emitter resistor out of circuit, and you can see one half of it is low resistance. So here we're showing 0.574. Of course if we zeroed the meter, then we could probably nominally read the 0.22 ohms, but you have to allow here for the electrical resistance of the leads, because it's only a 2-wire connection, not 3-wire, which would eliminate that. And then when I go to the other side of the resistor, you can see that the multimeter now is saying overload. So that tells you that the resistor is open circuit, which is a little bit odd. And the reason why it's a little bit odd is that normally if these resistors fail, it tends to indicate that there's been excess current drawn, and that means that maybe one of the audio output transistors has gone short circuit, which in turn has blown the resistor. But there is no indication of that at all. So all that I can presume is, for whatever reason, that side of the resistor pack just went open circuit, because there was nothing else, that was the issue. So of course this is what was causing the amplifier to trigger and then to go into protection mode. Now, to sort of strip down the amplifier, it is straightforward. So you just remove the back panel, and we'll get to that in a moment because there's some important points about that. And you have multiple fixing screws which just go through the top. And then you'll also find that where you have the heatsink, you've got this other sort of circuit board which has the multi-pin connector from the power transformer. And then here what I show you is the main board on the bench. You can see the top view. So this amplifier, because it's a more modern type, is a combination of component type. So it's both conventional and I'll say discrete components, so you can see individual capacitors and resistors, etc. And of course this is the same if you have like large electrolytics, they're not going to sort of miniaturize those down to surface mount. But if we turn the circuit board over, now what you can see is the surface mount components, and you have a number of integrated circuits on there, as well as small values, resistors and capacitors. So if this fault was probably more complicated than just the one side of the emitter resistor being open, you would probably kind of struggle, I would say, without the service manual, because ideally you would need the service schematics to sort of zoom in and look at each part of the circuit then to do fault finding. Now what I don't have in stock is the dual emitter resistors. I hold in stock the same resistors, 0.22 ohm, 5 watts, but they are individual. So here what I'm showing you is the resistor or the resistors, and what I've done is I've just took one of the leads and then I've then connected it down to the other side of the lead, effectively making a dual stack resistor. And then here I'm showing you the resistor in the circuit board, and it's a neat repair. You know, when you look at that, that's perfectly fine. And once the amplifier was sort of powered up, then the bias adjustment could be made, you know, to match the other channel. I think it's nominally about 10 millivolts for each channel, but if you look just to the left hand side, you can just about make out the preset adjustment or the trimmer, and that's where you'll then adjust that until you read your required millivolts across your test connectors then. So the other thing that I want to sort of bring to your attention is the power startup circuit board, because what I found was that the amplifier would run fine, but if I kind of flex the board just a little bit, sort of tapping it, then it would sort of shut off. And it's not the same fault as what you were seeing previously, where the amplifier was going into protection mode because of the issue with the bias adjustment. So here on the left hand side you can see the EI transformer, and this is the same brand, so it's this Bando transformer, and you see this commonly in a lot of the Pioneer amplifiers. And then what it does then is it gets the power directly from the vertical board, and then you can see that there's a smaller, probably 3 VA transformer, and that's the one which is generating the voltage for the microcontroller. And then when the relay energizes, there's also a protection fuse on there as well. It provides the voltage to the primary side of the transformer. And then here what I've done is I've just removed it from the amplifier, and there you can see the small VA transformer, 3 VA transformer, so that's the startup circuit. There's a protection fuse. You can see the multi-pin connector, 2 pins just where the transformer connects, and then also the small relay which is sort of in the center part. Now when you turned it over, what you've got is you've got 2 rectifiers on there. What I could see is that it was almost like cracking around a couple of the pins. So what I do is I just reflow all of those connections on the board just to make sure, and then once that was then reinstalled back into the amplifier, you know, you could sort of press down onto the board and you didn't find any sort of tripping or any sort of issue. And then the other thing which was sort of noticeable, and again this sort of came about during test phase, is if you press the standby button to bring the amplifier into normal operation, sometimes it would operate and sometimes it wouldn't. You sort of have to sort of press on it. Now this is a common issue that you see on amplifiers which use these momentary, almost PCB mounted push buttons. So what I show here is just the front fascia removed, and as with all amplifiers you have a multitude of screws which you need to remove them from the rear. And then also as well shown is just the encoder, which is for the volume control, and then just to the left there's also the small circuit board where you would have the headphone socket connections, but you can remove all of this circuit board. And then what I'm showing you here is the circuit board standing up vertically, so you can now see it from the front, and there's a series of small push buttons, and the one directly on the left hand side is the power switch. And if we sort of zoom in, what you can see is this miniature power button, and this is the push button that the microprocessor will read directly then to bring the amplifier out of standby mode, or in the same way it would read some of the other switches if you were selecting maybe a different speaker impedance or maybe direct mode or loudness. Now what happens is that these push buttons have a lot of usage over a number of years, and what you find is that the contacts become worn and then also oxidized as well. So the only thing that you can do is to replace that push button, and you see commonly on Cambridge amplifiers, on the 640 series, 340, you know, these are the types of switches that you see, and you just replace them. You know, you're not going to be able to sort of strip them down. All you can do, as I say, is just to replace. Now once that was done, then literally as you press the push button, then it would then switch out of standby mode every single time, and you didn't have to sort of put any pressure onto the standby button. So the next thing that I want to bring to your attention, and this is really, really important, and I sort of alluded to it earlier in the tutorial, it is not uncommon for manufacturers to use the rear back panel of an amplifier as a common ground connection. And this common ground connection is critically important, and you see it on things like Marantz amplifiers, for example, also Pioneer amplifiers. And this Pioneer amplifier, it's used extensively. So the first thing that I'm showing you is the rear back panel, and you can see the power lead coming in, and then I've just highlighted with a series of circles around holes. and these are the holes where the fixing screws go through and then mount or connect to the main chassis. Now, all engineers who work on amplifiers or electronic equipment, of course, you need to strip down the device, to get access to the circuit boards. But if you're going to enter into test phase, you need to fix these screws in place. If you don't, you'll find that this amplifier will not start. What will happen is if you press the standby button, it will flash and you'll hear the relay just click on and off momentarily, and you may be misled to think that there's another issue, or since you stripped it down and then reassembled it, then there's another problem which you weren't seeing previously. But that is not the case. It's this common ground connection. And this common ground connection, for those holes there, whenever you see one of these back panels where clearly there's no paint, it's not by accident that it's worn away, it's deliberately done. And then here what I'm showing you is a common ground connection, and this is for the power supply stroke startup board. And I've drawn a circle around it, and you can see where one of the screws goes through the back panel, and then it then connects to a common ground connection on the standby board. And then also there's a small link where it's connected to the rest of the circuit, but it doesn't end there. This common ground connection then comes in on the rear speaker binding post, and I'll put an arrow to highlight that. So again, there's no paint. That tells you it's been done with purpose. And what happens is when you put the fixing screw in place, what it will then do, and what you see, is that there is a ground connection which goes through the speaker terminals, and then that common ground connection now goes onto the circuit board of the amp. And then, if we move along, what you now see is the rear for the RCA input sockets. And again, I'm highlighting with a number of arrows here. So what I'm showing you is that there's no paint on any of those fixing holes. So that tells you again, it's been done deliberately. You can also see on the chassis, again, multiple holes, no paint. But on 3 of those terminals, the phony input CD, SACD, and then line 1, you can just about make out, but there is like a metal plate around each one of those. And again, if you don't put those screws in place, what you'll find is that the amplifier doesn't correctly start up. It'll effectively just keep tripping into a fault mode or non-start. So just to re-emphasize this point, whenever you're doing the strip down and repair work on this model or on other amplifiers which have this common ground connection, just be aware that even if you put part of the back panel on and only a few of the fixing screws, it may not be sufficient to ensure that all of the relevant parts of the circuit where they're using this method are connected commonly. And you can verify that. You've only got to put your meter onto conductivity resistance check, and I can quickly check to see if the speaker terminal ground connection is common then with the RCA socket common ground, and then also the startup board, and then back to main chassis then. So the next thing that I'm showing you is just general sort of visual of what's what. So you can see here the EI transformer. And as I said, this is very, very common. They use the same brand of manufacturer, this Bando type, on many of the amplifiers. And then here, when you look from the rear of the amplifier, what you're seeing is the volume encoder on the small circuit board. And as I said, when you remove the circuit board, once you remove the number of fixing screws, it's quite straightforward just to disconnect these multi-pin connectors, and you can quickly remove the board complete then. And then here from a top view, you can see on the right hand side towards the rear, that is the phono stage or the moving magnet input, and then that comes into the pre-amplifier stage. So we said you have the volume control and then also your tone controls on the front control board. And then just to the left hand side you have the emitter resistors and your output transistors. And the big electrolytics are sort of vertical, sort of the black canisters. And then you have some audio grade smaller capacitors for filter capacitors and maybe coupling to the relevant circuit. And then, as I said earlier, you can see this small circuit board which is screwed to the top of the heatsink. So connects via a multi-pin connector then to the main amp board. So when you sort of do the disassemble, you'll need to remove that. Also as well, just be aware that the back board, which you can just get in iShop now, you'll need to remove the fixing screws there before you can withdraw the amplifier board out of the chassis. And then finally, just the top view, so you can see the amplifier here. So it's sort of in its test phase. So this is where the amplifier will go through a number of different tests. But of course, because we had this sort of intermittent issue, which was also linked to the amplifier going into protection mode because of this DC bias issue. This amplifier was probably left on test for about 4 to 5 hours, and then a number of power cycles are repeated just to ensure that the amplifier is functioning correctly. And then here you see the offending emitter resistor, and then finally you can now see the amplifier working. And what I would also mention as well is this is the first time that this particular model of amplifier has come into the workshop. I've not seen this model before, so it's good to make a repair tutorial for future reference, because I would imagine that as these amplifiers age, I will start to see more of them come through. And as always, I appreciate you stopping by, and if you need any help, support or guidance, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to help provide you with any information or support that you may require. So until the next time, all the very best, cheers and bye bye.